Okay, so in this video I'm going to explain the solution to number 1b of small letter b. The question is about determining if an equation if it's a function or not a function, or we could say a mere relation. So the equation given is y equals the square root of 3 plus 2x plus x squared. Now, to answer this question, we have to go back to the concept of functions. Like, when do we say that a given equation will behave as a function? Okay, so for relations to be functions, you only have to consider a special relationship between two sets. Okay, the rule is one element coming from the first set should always be paired up to a single element on the second set. So the relationship is 1 to 1. Okay? So some would say many to 1, but many to 1 is also coming from the concept of 1 to 1. Because many to 1 is like, says this is an element and then there's another element. So this element goes to an element of the second set. So that shows a 1 to 1 pairing. Okay? And then a second set here, a second element rather. So this element could go also to that same value. But again, as you can see, the behavior is a single element going to a single element of the other set. So we could say this is a many to one relationship or pairing, many to one, because you could see many values of the first set going to a single or one value of the second set. So it's many to one. Okay, but basically the idea is coming from 1 to 1. Now to summarize, okay, the idea of functions, always keep in mind that whenever you get an element from the first set, you always end up with one element on the second set. Okay, so to elaborate that, let's take an example in which you cannot have a function. So suppose I have this set 1, 2, and 3. So this is set A, and there's another set B. Say it has 4, it has 5, then it has 6. So the pair up could be 1 is going to 4. Now 2, instead of going to 5 or 6, 2 is going to 4. Okay. Now, and then 2 could also go to 6, and then 3 goes to 5. Okay, now I want you to focus your attention on the element 2. Okay, now although 1 follows the condition, it goes to a single value 4, and 3 goes to a single value 5, take a look at 2. A single element in the set A is going to many values in B. So it's violating the rule that it has to go to a single value, because as we can see, it's going to more than one value. So this pairing is not a function. This is just a mere relation. So that's the idea of functions. Now going back to the main question, because we are dealing with equations and not diagrams, but these equations are actually just another representation of the diagrams. Now, by convention, the first set is always coming from the value of x, and then the second set always are the values of y. So if we look at this equation, we are considering if I identify a value x, say 1 or 0 or 2, will that give me just a single value of y? Because if that is the case for all x that I put in this equation, then I would say that this is a function. Okay, so let's investigate. So we have the y equals the square root of 3 plus 2x plus x squared. Suppose I select x equals 1. So if x is equal to 1, then the y will be the square root of 1 plus 2 times 1 plus 1 squared. And if I compute for the value, this will be the square root of 1 plus 2 plus 1, and this is the square root of 4, which is equal to 2. So the value x equals 1 is just leading me to a single value y, which is 2. So somehow, with one example, it is showing that this equation is a function. Okay, but you could say that's just one value of x. Maybe for other values of x, it will not work anymore. But if we have to consider the structure of the equation, so just imagine putting any number of x. Okay, any number x. You square that number, you add it to 2x, 2 times that number plus 3. Are you expecting more than one value? I don't think so. So whenever you put a single value of x here, the whole thing inside will just be a single number. And the square root of that number is just one number, right? So any x that I'll put on this equation will always give me a single value of y, because the square root of a number is just a single number. Okay, right? So like y, and then there's a random number here. You're taking the square root of the number. Can you expect that to have two values? No, it's always one. So this equation is behaving and satisfying the condition that for every x that I put on the equation is always a single value of y. Okay, so I think one of the confusion on this type of equation is when you have like a y squared equals 3 plus 2x plus x squared. If you take a look at this equation and try to get y from this equation, you will get plus or minus the square root of 3 plus 2x plus x squared. That's what we learned before. If you want to get the y and it's raised to 2, you take the positive and the negative square root of the other side. Now, here's the big difference. The first case is saying y is equal to the square root. Square root is positive square root. Otherwise, I'll put a minus sign there, and it means negative square root. Okay, but it says positive square root. Okay, now in the new equation, so after getting the square root of the other side, we have to consider plus and minus. So now this is a big there's a big difference now, because when you put a number x, any random x, and you get the square root of that number, whatever number is the result, the y can be the positive of the square root or the negative of the square root. So every x, if you put an x value inside, okay, so this one, it could lead you to the positive or the negative of the square root. So this is an indication of one to many, which is not a function. Okay, so here you could see now the big difference. Okay, just by looking at the structure of the equation, it says y is equal to the positive square root. Y is always a single number, so every x there's a single number or a single value of y. Okay, so the y equals the square root equations will always be functions, and those that are like y squared, so this one, they're like y squared. Because of the square, when you look for y, you always take the positive or the negative square root, so it's leading you to more than one value of y. So the y squared equations will just be mere relation. Okay, so let's summarize that. Okay, so we took a look at y equals the square root of 3 plus 2x plus x squared. This is a positive square root. Put any number inside, or put any number to x. Take the square root of the result. That's always a single number. That is why this equation is a function. Okay, now in the same test, there was a follow-up question, the letter C, that you could have like you could apply what we learned from here. So on letter C, the question was, so same, determine whether it's a function or not a function. So take a look at this. This is already y squared. So when you simplify this into 1 minus x, that's subtracting x on both sides, and then divide by 2. So y squared is equal to 1 minus x over 2. So upon getting the y, this could lead to plus or minus the square root of 1 minus x over 2. So you are now expecting two values of y. So the letter C is a mere relation. Okay? So some easy clues, you see a y squared that's leading to a mere relation, and it cannot be a function. Okay, so I hope that this video was able to help you understand how to identify equations, whether they behave as a function or they're just mere relation. Okay, so that's it.